Hello everyone, I hope you're enjoying your week so far. We're going to take a second to talk about some reciprocal trig functions from Unit 10 on trigonometric functions. So we all know that reciprocal means to flip over a fraction. So we're going to look at what reciprocal trig functions are. We've already defined three basic trigonometric functions, which are sine, cosine, and tangent. There are three other trig functions that can be defined in terms of sine, cosine, and tangent, and they are referred to as reciprocal functions. So if I asked you to tell me what is the reciprocal of sine, I should have put thetas after these. If I ask you what's the reciprocal of sine theta, hopefully you would say 1 over sine theta. If I asked you what's the reciprocal of cos, you would say 1 over cos theta. And if I asked you tan, what's the reciprocal of that, you would say 1 over tan theta. That's what the reciprocal functions boil down to. Now there's different names for them, but it's essentially the same thing. You're taking and flipping each of these functions over, putting in one on the top and taking care of the bottom. So the first one I'd like to talk about is the cotangent function, and that is represented as just COT, cotangent. It's the reciprocal of tangent. So cotangent of theta is 1 over tan of theta, or cosine theta over sine theta. And this one is kind of a little bit extra. We'll talk about that a little more later, so just write it down for now with these fancy little stars around it. Cotangent will be undefined when tan is equal to 0. So tangent is equal to 0, if you recall, at 0 degrees, 180 degrees, 360 degrees. So that is where cotangent will be undefined. When tangent is undefined, which was 90 degrees and 270 degrees, cotangent is going to be 0 because you're flipping it over. So the 0 is now on top instead of being on the bottom. If you remember, at 90 degrees, it is 1 over 0, which is undefined. If you flip that over, cotangent is 0 over 1, which is just 0. Secant. Now this is another new one. Secant is represented as SEC. Secant. It's the reciprocal of cosine. So secant theta is 1 over cosine of theta. Since there is no reciprocal of 0, secant is undefined whenever cosine is equal to 0. And that was at 90 and 270. So again, same idea. At 90 and 270, it is 1 over 0 and negative 1 over 0, which when you take and flip those over, they just become 0. Or sorry, they become undefined. The last one is cosecant. The only thing that's left, this is represented as CSC, cosecant. And it's the reciprocal of the sine function. So cosecant theta is 1 over sine theta. It will be undefined when sine theta equals 0, which is at 0 degrees, 180 degrees, and 270 degrees. And it's the same idea as before. If you have a 0 on the top, when you flip it over, it now becomes undefined. This last section down here you can cross out because we already covered that. I forgot to delete it out when I changed the order of some stuff there. The table here, the signs of the 6 trig functions in each of the quadrants. So we have the first quadrant, second quadrant, third quadrant, fourth quadrant. And we've already done the top part of this table. So we know that our phrase was all students take calc. Right? So in the first quadrant, all things are going to be positive. In the second quadrant, sine is positive, the rest are negative. In the third quadrant, tangent is positive, the others are negative. And in the last one, cosine is positive, and the others are negative. If we're looking at the reciprocals, it keeps the same sign. So we know that sine matches up with cosecant. So that means that down here is going to be a positive. We know that cosine matches up with secant, so we're going to have a positive here. And we know that tangent goes with cotangent, so we'll have a positive here. So you can follow that same pattern. If you have a positive for sine, it's going to be a positive for cosecant. If you have a positive for cosine, it's going to be a positive for secant. And if you have a positive for tangent, it's going to be a positive for cotangent. And then you should be able to fill in the rest of your negatives there. So in the second quadrant, cosine is negative. So secant is negative. And tangent is negative, so cotangent is negative. Similarly, in the third quadrant, sine is negative in the third and fourth, so cosecant is negative in the third and fourth. Cosine is negative in the third, secant is negative in the third. Tangent is negative in the fourth, cotangent is negative in the fourth. Okay, so we want to remember that sine matches with cosecant, cosine matches with secant, and tangent goes with cotangent. So you'll never have a co with another co. Cosine doesn't go with cosecant. You can't have co's together. And you can't have s's together. The sine and the secant can't go together. A couple examples very quickly. The terminal side of an angle in standard position intersects the unit circle at P, which is this point here. If the measure of the angle is theta, find the 6 trig values. So we should be pretty straightforward with a couple of these. So let's start with cosine. So cosine of theta and sine of theta should be really straightforward. Because remember that these are not only x's and y's, but it's also cosine, sine. So cosine of theta is going to be 5 over 7. And sine of theta is going to be negative 2 square root of 6 over 7. Tangent, if we recall, is sine of theta over cosine of theta. So that means it's going to be negative 2 square root of 6 over 7 over 5 over 7. And we're lucky enough that those 7's will cancel out. And we'll be left with just negative 2 radical 6 over 5. Finding the other functions should be a little bit easier now because we're just taking the reciprocals. So to find secant, which goes with cosine, we just take the reciprocal. So the reciprocal of 5 over 7 is 7 over 5. Done. Cosecant, CSC, is going to be the reciprocal of sine. So that's going to be 7 over negative 2 radical 6. And you can't leave this like this because there's a radical on the bottom. So if you remember rationalizing the denominator back from the chapter on radicals, you need to multiply by the square root of 6 over the square root of 6. So this becomes negative 7 radical 6 over, well, this is 2 times radical 6 times radical 6 is 6. So that's 2 times 6, which is 12. Let me rewrite that so it's a little clearer. 7 radical 6 over, and if you wanted to, you can leave that negative on the bottom, so negative 12. And cotangent down on the bottom there, cotangent, is going to be the reciprocal of tangent. So it's going to be 5 over negative 2 radical 6. And I would like you to go ahead and try and rationalize that denominator on your own. So figure out exactly what cotangent is equal to, and I will tell you in class tomorrow exactly what that answer is. The next example here. These types of problems, there's one trick to it. Get everything in terms of sine and cosine. It says show that tangent of theta times cosecant of theta is equal to secant of theta. So we need to get both sides to look like they're exactly the same. The way we go about that, like I said, is to make everything in terms of sine and cosine. So tangent is sine over cosine. Cosecant is 1 over sine. And secant is 1 over cosine. Now, if we were multiplying these, which we are, there's no sign, so it's multiplication, we should be able to tell that this sign and this sign cancel out because you have 1 on the top and 1 on the bottom. So if these cancel out, we're left with 1 on the top over cosine on the bottom, and on the other side it's just 1 over cosine. So these are exactly the same. We have now shown that no matter what the angle measure is, if you take the tangent, multiply it by the cosecant, you end up with the secant, because this down here shows that they're both true. All we did was change what they looked like. We changed tangent to sine over cosine, we changed cosecant to 1 over sine, and we changed secant to 1 over cosine. And when you multiply that out, it ends up to be exactly the same. And the last example here, we're actually going to go over in class. It'll be the first thing we do. It's not really tricky, but the video is getting a little long now, and I want to make sure that I keep it kind of short. So, if you have any questions with this, jot them down in your notes. Make sure you ask me when you come into class. We'll go over number 3 here, along with that other problem where I asked you to rationalize the denominator. Have a wonderful day.